Good morning, and I don't know what week it is. I'm like you. I probably lost just like you are. We're well deep into the semester. That's all I know, and I think we're about ready to wrap up the whole LCA analysis, and I hope that you've gotten enough out of it to understand it. Remember, this is just an overview. There is a course that's offered in Arkansas as part of the certification program. It's a very good course that goes very deep into the LCA. And spends the entire semester doing those LCA analyses. So, and if you're interested in this, I'd encourage you to sign up and take that course. Okay, I want to talk just a minute about some of the alternatives to LCA analysis. And really, like I said before, LCA is basically an accounting tool. You can account on the, you can count for the energy flows, nutrient flows, any one of the elements you can look at as a flow of that, as we've done with carbon dioxide or global warming. So that's a great tool for that. I think it's a good way of accounting for what's going on. But there are some other tools that are just as important that have a similar type of meaning, but aren't the same kind of accounting tool. One of those is, you'll hear frequently, and I've referred to this in the past, is the triple bottom line. And that approach really tries to take a look at the economic, the resource, and the social implications of the process that we're studying. And you see that's a little bit more reaching, because all we're doing is basically the accounting of materials or nutrients or some sort of material that we can put our hands on. We're not looking at dollar values. We're not looking at social ramifications or what the impacts might be on how you live or your perception of the quality of life. So those things are not included in that LCA. It's strictly an accounting process, much the same as you have an accounting process in finance and account dollars. So the triple bottom line is certainly important. You can. What I'd like to have you do is just do a little online search to look at triple bottom line. See if you can find a article on triple bottom line. If you can find one on some of the energy products, that'd be great. But if you can't, I know there's studies out there on triple bottom line. There's some studies out there that are pretty good and have looked at overall. In my role as an economist, I will typically do more of the triple bottom line than I'll do the LCA. And the only reason that is because really my analysis is typically designed for policymakers, and they're really not interested in the material flows or the energy flows. What they're more interested in is, how does this thing affect their district? And so you want to look at, again, those economic impacts, those those natural resource impacts, and those those social impacts, because that's what they're most concerned about. In Congress, they're concerned about equity, the movement of things between people, and not so much about efficiency or any of the nutrient flows, energy flows, those kind of things. So anyway, go ahead and I'd like it if everybody try to post at least one article that you could find on triple bottom line, and then we can have a little discussion about that. One other tool that is just coming into use, that is a really well-known tool and highly used for a lot of things, is called input-output analysis. There's one model in particular that is well known, and it's managed by University of Minnesota. It was built by Department of Agriculture's Forest Service in Fort Collins, Colorado, and it's called IMPLAN. The model is called impact planning, and it was designed for the Forest Service to look at how they do changes in forest management and what the implications of that would be. But this is a model that's much like a hybrid between the LCA and triple bottom line. The IMPLAN model itself is pretty much an accounting tool. What happens is that it is a dollar value model that looks at the economy-wide impacts. And when I say the economy-wide impacts, it's the same thing as that LCA as we talked through that and said, let's look at corn production. Corn uses inputs, and then those inputs use inputs. And those are called production functions. And the input-output model uses those production functions in the same way, only instead of actually accounting for energy flows or material flows, it looks at the dollar value of that. So it says, let's suppose I want to produce $1 value of ethanol. That would require an X dollars of labor, X dollars of steel, X dollars of fertilizer, et cetera, all the way down. And then those things require dollars, and then also the labor. Then when you say how much labor does it require, let's say it costs 50 cents of labor. Well, that 50 cents then is spent on other goods and services that require other labor ad infinitum. And so that model comes up with a multiplier that says for every dollar of ethanol that's produced, I have this many dollars of industrial output and economic activity. And typically that's a multiplier, and it's typically in that ballpark from, say, 1.5 to 2.5, which means that for every dollar of ethanol I produce, I generate about $1.50 to $2.50 of economic activity. And recently, there's been criticism of the in-plan model for not including the impacts on, just like GDP, which is a measure of the value of final goods and services produced in the United States. Neither of those have a measure of what happens to the assets, particularly the natural resource assets in the United States. Are they increasing or decreasing because of that economic activity? And that's a very important concept that is now being included into the in-plan model, is that resource linkage. So it's not going to be just what's the economic activity related to that production function. It'll also be capturing the asset values of the resource. So in terms of the water resource, as you have a production process, that water resource may be more utilized or more used up than another process, and that would be a detraction from the value of that economic activity. And so we're working on that. It's an interesting one. You might want to look at input-output analysis, do a little review of that, and see if you can find an analysis that's been done recently using the environmental tool. I'm not sure if it's been out there long enough for that to happen. I know here at Oklahoma State we are doing that very thing with respect to energy. If you want to contact one of the faculty members, you can contact Dave Scheidler in agricultural economics. He actually has the model and is running it. We have a couple of grad students that are actually working on that project right now. And I don't know whether that has been done, because it's a fairly new tool, whether that's been done on the literature yet. So go ahead and look for it. If you find something, I'd be appreciative if you post it. That's all. Please take the time to understand what those LCA alternatives are and what the good points and bad points are with respect to LCA analysis of each alternative. All right, see you next week.